As usual, I'm going to show you a data sheet from a former student of mine. It may have a different format of the one that you're receiving in this activity via Canvas because this was done in lab using a different set of glassware and perhaps a bit of a different approach. But nevertheless, it should work out. This is one trial from my former student, Matt. Uh, Matt actually went on to become a lawyer. And I heard he had an accident and lost his eyesight, but continued his practice and had a very interesting lifestyle up there on the East Coast. So I haven't seen him again, but I hope he's doing well. So this is data that Matt obtained when he was my student. I'm only showing you one trial, but I'm going to show you later on what's going to happen. You will receive a data sheet similar to this, where you will have 3 trials worth of data. Remember, in the experiment, you are going to take the flask in which you perform the experiment. After you're finished, you're going to fill it up with water and find the flask volume. In the lab itself, the way we did it was we used actual Duma bulb flasks, and these were marked with etched symbols on the neck of the flask that you went to a table and found the actual volume. In your data sets, your flasks have also been labeled and they have volumes that have been pre-recorded. Some of them have been done to 1 decimal place, some of them to 2 decimal places. So in Matt's case, he had a flask that had a volume of 276.5 milliliters. The pressure on the day of the lab was 755.0. And then you see the mass of the empty flask and then the mass of the flask after you have recondensed the liquid. In the typical experiment, what you do after this is you don't pour off the condensed liquid. You simply add another sample into it, and then you repeat the experiment. Remember that you're always starting with an excess of the liquid, so you don't really care about how much liquid you started with. Your concern is how much vapor was in the flask after it all vaporized, and that amount which is then recondensed, that is the mass you're concerned about. Notice that I asked Matt and the students in his class to record the temperature of the boiling water. In other words, to not assume that our water was boiling at exactly 100 degrees. Okay, so let's analyze this. The first thing we want to do is, as always, I like to put numbers in these things here so we can have a track of the values. So I'm going to start here with the flask volume. I'm going to put that at number 1, and then I'm going to continue putting values here. And I think in your case, we were not asked to record the data down here, so you can, for the most part, ignore these lines here. This is from a previous data set. The temperature, of course, 99.5 degrees. And then what we're going to do is we're going to continue here. Let's see, this is going to be over here. Let's say the temperature will be number 5. And then this is 6. This will be 7. This will be 8. This will be 9. And this will be 10. And again, sorry that some of the video is getting chopped off a little bit here. Let me see if I can move this a little bit here to the left so you can see it a little better. There we go. As always, I request that you display your calculations on a separate piece of paper, and we do this in pencil so that any errors we make, we can erase in a neat way. So the first thing we're going to calculate is item number 6. What is the mass of the unknown? Well, that refers to what is the mass of the recondensed liquid, right? So this we said is item number 6. I'm gonna put it here. This is the mass of the vapor or the gas. So that would be the difference between the full flask and the empty flask. That would be items number 4 minus item number 3. And the values that we had here were 104.1834 minus 102.0702. And that calculation yields a value of 2.1132 grams. So I'm going to put that number over here, column 6, 2.1132. Since the units are already indicated here on these labels, I don't need to repeat the units over there. It is obvious that what we're talking about is grams. Now we're going to find out how many moles of unknown were there. To do this, we're going to be using the ideal gas equation. So this will be item number 7, number of moles of gas, and that would be PV over RT. Now we have all these values here, but we have to convert them to the proper units because the gas constant uses liters atmospheres per mole per Kelvin, correct? So we have the pressure here, which was 755.0 torr. We have the temperature here, which is 99.5 degrees Celsius. We have the volume, 276.5 milliliters. So all of those we're going to have to convert to the proper units. So let's go ahead and do that here. We have 755.0 torr, which we had to convert to atmospheres. So we know that 1 atmosphere is 760. I'm going to go ahead and make it exact torr. The volume we said was 276.5 milliliters. But if we convert that to liters, that would be 0.2765 liters. And over here, we have our good friend, the ideal gas constant, 0.08206 in units of liters times atmospheres per mole per Kelvin. And now we have our temperature, which we recorded at 99.5. In your initial original lab manual, you were told to assume that the temperature was 100 degrees. And then they asked the question in the post-lab, well, what if it isn't 100 degrees? Well, we dispelled that argument by actually measuring the temperature. So this is 99.5 times 273.15, and this is going to give us the temperature in Kelvin. Okay, let's make sure the units cancel out. So we have torr here canceling out with torr, atmospheres with atmospheres, liters with liters, and Kelvin with Kelvin. And since the moles here are in the denominator of the denominator, they're going to flip up and they're going to give us a final value in terms of moles. You can use decimal or you can use scientific notation. When we do these calculations, I get 8.982 times 10 to the negative 3 moles. Again, all of these values here experimentally, the pressure and the volume have 4 sig figs. Even after rounding the temperature, we're going to get 4 sig figs. So we should be fine with expressing the number of moles this way. So according to the ideal gas equation, we should have in here 8.982 times 10 to the negative 3 moles of gas. Again, remember, this represents how much of the vapor was present in the flask at the temperature we measured for the boiling water and against an outside pressure of 755.0 torr. Now we're ready to calculate what is the actual molar mass according to this trial. So this is, as we saw here, item number 8, molar mass. That's grams per mole, so that should be basically item number 6 in grams divided by item number 7 in moles. So we had for the mass 2.1132 grams, and we had 8.982 times 10 to the negative 3 moles. Put that in our calculator. We have a limit of 4 sig figs over here. So that's going to come up to be 235.3 grams per mole. And from this first trial, therefore, we get a number here, which is 235.3. And we can write the units here, grams per mole, so we don't have to repeat them and take up room here and make it confusing. Remember that the idea of all this is to make it clear to an outside person who's reading it and they're trying to kind of understand what we did. That's why, again, our calculations page should be fairly neat, not chicken scratch, right? So, okay, I don't have the rest of the data, but for the sake of this example, let's assume that now Matt did a second trial and a third trial. And let's say that when they calculated those numbers, they got here 240.2. And then for this one, they got 237.5. Okay, I'm just giving you some numbers here just to play with so we can show you how to do these calculations here. The percent difference, we've usually done it for 2 data points at a time. So we're going to do a little adjustment here. Now, actually, what we're interested in, what was the average molar mass? So let's go ahead and calculate that first, okay? I'm going to jump ahead here to item number 10, which is the average molar mass. So remember, that's the, let's go ahead and do a double M in there. We're going to take this for the 3 values. So the values that Matt got was 235.3 plus 240.2 and 237.5. And there were 3 total items. So let's see what that comes up to be. Here's my calculator. So 235.3 plus 240.2 plus 237.5. And we get this number. Now remember, although the calculator is displaying this at 713, we know that in our input values, there was a decimal. So that means that technically this should be 713.0, which is 4 sig figs. When we divide that total by the 3 items, because the 3 is an exact count, we don't consider it towards sig figs, but our final result should have had the extra decimal. In other words, it should have the 4 sig figs. So 237.66666. So we're going to round that to 237.7. And of course, the units were grams per mole. And that's the number that we're going to put in here in our box for the average molar mass, 237.7. Again, this is units of grams per mole. So that's the molar mass of this unknown liquid based on the three trials. Now, how reliable are the results? How confident are we of them? We're going to find that from the percent difference. Now, typically what we've done with percent difference is we have taken two values at a time, subtracted them, taken the absolute value of the difference, and then divided by the average. But in this case, you're going to be receiving three trials. So the way we're going to do it is to calculate the percent difference, which is actually item number 9. I kind of skipped, okay? Percent difference. How we're going to do it is we're going to consider the highest versus the lowest value. So this will be the absolute value of the highest molar mass minus the lowest molar mass divided by the average. And since it's going to be a percent, we're going to multiply that times 100%. Okay, this is the way we're going to do it, and this is what you'll do with your data. So our highest value was 240.2. Your lowest one was 235.3. We'll keep the absolute value in there, even though by the operation itself, it's not going to matter. The average we calculated was 237.7. All of that times 100%. All right. So let's see how this works. You got to be careful with the sig figs here. So I'm going to block this for a moment here so you can see the display here. And let me move it to the side. Okay, so we have 240.2 minus 235.3, and we get 4.9. Notice that we keep one decimal for this operation. We're not going to round anything, but this tells us that the top part of that operation carries only 2 sig figs. So we have to round our final result to 2 sig figs. Let's divide that by 237.7, and then let's multiply times 100, and that gives us 2.06142196. But remember that the top part of that operation only carried 2 sig figs, so we need to round this to 2 sig figs. So that'll be 2.1. So our final result here is 2.1%. Okay, so this is the difference from what we've done in the past. But whenever you have multiple sets of data, many times the way we do it is in the absence of any further, more sophisticated statistical analysis like variance and standard deviations. We just simply take the difference between the highest and the lowest data points that we got. So we come back here and we're going to say here, this is 2.1%. So this is how you will calculate your numbers for this lab. This is how your data will be displayed. Of course, in your case, you are going to have these two columns filled in. So you will have to fill in the remainder cells in this table. In terms of your calculations, don't forget, you will have to submit your calculations page because the three trials represent repetitive type of calculations. You're only required to show one set of them. So for example, in this case, we showed just trial 1, and that is enough. Now, you also need to display, besides the calculations for trial 1 or 2 or 3, you also are required to present, to show the calculation of the average and the calculation of the percent difference. Also, don't forget, as part of your lab report, you are going to have also a couple of discussion questions for your post lab. So please read your assignment properly so you can know what those questions are, and those will be part of your lab report. That is all. Thank you very much.